Hi guys, so in a previous video I ran some benchmarks on a 16 drive system with two LSI SAS2008 HBA IT mode controllers, and I have here on the left the benchmark results that we got from that video. And one of the questions I get often from people who are buying from my eBay store called the Art of Server is that there are other newer HBA controllers out since the 2008. 2008 is pretty old now. It's still, as you can see from the benchmarks in that video or in front of you here on the left side, it's still fairly relevant. If you're just using regular hard drives, it's perfectly adequate for a lot of use cases. So in spite of its age, it's actually still very, very useful. But there are newer SAS controllers out there now, and in particular, one that's one generation newer than the 2008 is the 2308. And so today I'm going to run the same exact benchmarks that I did on the 2008, except this time I'm going to use the 2308. And so I've basically kept the same server, same hard drive, same everything, other than the 2008 controllers have been swapped out for the 2308. And we're going to see if the newer 2308 makes any difference, for the benchmarks that I'm running here and for the configuration of 8 to 16 spinning hard drives. Now, of course, if you have a different hardware configuration, there could be a difference, and so some of the advantages of the newer chipset might be more pronounced. Say, for example, if you're using SSDs. Anyway, let me put the results from the last benchmark away for now, and I kind of want to begin this video by just talking about the architecture differences in the two different chipsets, so that we have kind of this background as we're looking at the results to see if there are any differences. So on the left here is the block diagram for the old SAS 2008 chipset. As you can see, it has 8 6 gigabit SAS ports. It's got a PCIe 2.0 interface to the host at 8 lanes, so giving it about 4 gigabits per second, and it's got a PowerPC processor running at 533 megahertz. Okay, and on the right side here is the block diagram for the newer 2308 chipset. And you'll see that it's basically the same on the bottom here. It's 8 ports, SAS 2 6 gigabit, and everything else is more or less the same. The memory bus here is a little bit narrower, but that doesn't really matter that much. And the main differences are up here. It has a PCIe 3.0 interface to the host instead of a 2.0 interface, so this is newer. However, for full disclosure, the server that we're running these tests on, it only supports PCIe 2.0, and so this is going to be downclocked to the or negotiated down to the PCIe 2.0 speed instead of PCIe 3.0. So we won't be taking advantage of this, but this may or may not matter. So I don't think we're going to get close to 8 here. So, and then the other thing is we have the same PowerPC 440 processor, except that it's running at 800 megahertz instead of 533 megahertz. So this might result in a difference. We don't know until we actually run the benchmarks. I actually haven't run the benchmarks ever here, so this is going to be the first time I'm going to do it. But I just want to kind of keep this contrast, the differences between the 2008 and the 2308 in context as we look at those results. Alright, so I've set up the same spreadsheet as I've done in previous benchmark runs. It's exactly the same, except I've emptied out the data so we can put in new data from today's run. And let me get rid of that diagram here, so we have the terminal screen here. And also I'm going to minimize this window as well, and then we'll bring it back up as we fill in the data. But anyway, just for review, in case you haven't seen the previous video, I'm going to run 5 different configuration scenarios. I'm going to have a RAID 0 on 8 hard drives. I'm going to have a RAID 0 on 16 hard drives. I'm going to run ZFS RAIDZ2 on 8 hard drives, same RAIDZ2 on 16 hard drives. And then I'm going to run RAIDZ2 on 2 sets of 8 hard drives. So basically 2 VDEVs. So this is probably the more optimal configuration. But anyway, although you lose a little bit of space because of the higher level of redundancy there. But anyway, these are the different disk configuration scenarios. And again, this test is using the same exact disks as last time. So that's why I'm keeping the numbers here for the single disk test. This is really not going to change. It's the same exact hard drives. And we're seeing here for the DD sequential write on 1 megabyte blocks, we get about 208. For the DD test on reading 1 megabyte blocks, we get about 200. And we're going to use IO zone in the write, read, and random IO tests. And these were the results we got for this is the write, this is the read, here's the random write, random read, and anyway, those are the results we got for the single hard drive. Now we're going to see how this looks like we're going to start with the 8 drive RAID 0. Alright, so I'm going to minimize this so we have our screen here. Just to kind of quick overview, I'm going to be doing the configuration and running the benchmarks on the left terminal here. On the upper right terminal, I'm going to be running IOStat or zpool IOStat, so we can kind of see what's going on with all the drives. And then on the bottom here, I'm going to run top, refreshing at 1 second intervals, so that we can see how the system load is behaving. And also in the DD tests, I'm going to be dropping the cache, so we'll keep an eye on the amount of free memory here so that we can confirm that the cache has been dropped. Okay, so let's go ahead and first let me just show you the hardware. I'm going to run LSPCI and I'm grep for LSI. And by the way, I have another video if you're interested in learning on how to look at your hardware on the command line. There's a video, I'll leave a card in this video so you can click on that if you want to learn some of the commands to look at your hardware. But here's LSPCI, and I'm looking at the LSI. Here you can see the SAS controllers, and as you'll see here, it's the 2308 chipset, and I've got 2 of these. Okay, each one of these is directly connected to 8 hard drives, and I've got a total of 16 hard drives here. Okay, so B through Q. And the first test, we're going to just set up a RAID 0 on 8 drives. So I'm going to go ahead and pick the first 8 drives here. So that would be B through I. All right. So let's let me just highlight that. So I'm just gonna keep my eyes on it. Okay. We're gonna create, call it dev MD0, and 8 devices. We're gonna do RAID 0, and I'm gonna leave the chunk size out of this. I'm just pick the default. That's what we did last time. And I'm going to assume clean so that we don't have any background initialization going on while we run these tests. And we're going to do this B through I, right? Yes. Okay. And we need to format this. Okay, our formatting is done. We're going to go ahead and mount this on /data1. Alright, so now we can get started with our test. Okay, just as before, we're going to run this test with 1 megabyte blocks, and we're going to do 10 gigs. And again, just for review, in case you haven't seen the previous video, this machine has very little RAM. It's got a total of 4 gigs of RAM. There will be some caching, obviously, because when we have some spare memory here. But for the most part, when we're writing 10 gigs, this is going to, exceed the capability of being able to cache all that in whatever RAM we have. And so anyway, the results should be fairly true to what the disk I/O subsystem can do, rather than what the cache is doing. So anyway, let's go ahead and start this. So we're seeing about 1.5 gigabytes per second writes. okay, or 1.4 at the end. Okay, and we're going to go ahead and drop the cache now, and you'll see the free memory here has dropped because as that file was being written, that was getting cached. But we're going to drop that, and so you'll see now the memory is freed. So we're going to go ahead and now read that file back at 1 megabyte block sizes. Okay, so we got 1.5 gigabytes per second. Alright, let me go ahead and record this. We're going to record this in megabytes, so I'm just going to do a little conversion here. So I'll record that. I'm going to just round it up. So I'm going to record that as 1434. And for the 1.5 gigabyte read, we're going to record that as 1536. Okay, and just for a quick preview, let's see how that compared to the last test. So basically, it's identical at this point, and which is kind of what I expected. I don't really think the newer controller is going to make a big difference in sequential I/O. All right, so next is to run the I/O zone test. Alright, sorry for the interruption there. I was hoping that the I/O zone test command was going to be in my history, but apparently a lot has happened since then. It's rolled out of there, so I went back to just confirm exactly what the test I ran last time was. So we are running the exact same test. So basically it's going to be I/O zone with 16 gig file. We're going to do 1 megabyte records. We're going to run the write test, the read test, and the random I/O test. We're going to do one thread and a stride size of 64, and I'm going to record some CPU utilization. So this is the same exact test that was run last time, and let's go ahead and see how this fares. Alright, the tests are complete. Let's go ahead and record some of these results. So we'll start at the top here. And again, I'm going to do the same method I did last time. I'm just going to take the average. And so for the initial write, we have this number here. I'm going to round it up to 9. And we're recording this in megabytes, so I'm going to record that as 1431. And now let's look at the sequential read. That would be this one. I'll round that up to 90 in megabytes. 1407. Okay, and then in random writes, I'll record that as 558. And random reads, round that up to 6. I'll record that as 96. Okay, so the next test will be on a 16 drive RAID 0. Let's go ahead and set that up. Unmount this, and let's see here. Have the first 8, so let's do MD ADM stop. Okay. So So this time we're going to create the RAID 0 with 16 devices, and that will be B through Q. Yes. And we'll go ahead and format that. Oops. Oops. Okay, so formatting is done. Let's go ahead and mount this. Alright, so we're going to start off with our DD test, writing at 1 megabyte blocks for 10 gigs. Alright, and then we're going to drop the caches, and then we're going to do a read test. Okay, results are in. Go ahead and record this at 1.5. That would basically be the same as the previous here. At 2.3, at 2355. Okay, and let's go ahead and do the IO zone test now. Okay, the benchmarks are done. Let's go ahead and start recording this. So you got some pretty good numbers here. I'll record that at 1624. And on the read, round that up to 2. I'll record that as 2033. And then on the random write, round that up to 4. I'm going to record that as 1413. And for the random read, I'm going to record that as 97. So just a quick preview of the comparison between the 2008 and the 2308. Let's see here. Yeah, so for the 8 disk RAID 0, we're really not seeing much of a difference at all. For the 16 disk RAID 0, well, we're seeing a little bit improved, about almost 100 megabytes of improved sequential writes. Sequential reads about the same on the DD test at least. Sequential writes from IO zone a little bit lower, but really not a difference. And we're seeing slightly lower sequential reads as well, about 100 megabytes lower, but not really much of a difference. Random IO is almost identical, and yeah, for both read and write. So we're still seeing the same symptom that we've seen in the past, where the random reads basically the same, for any of these arrays, is basically the same performance as a single disk. On the random writes, we're seeing the scale up as we add more hard drives and whatnot, but it's essentially remaining the same as in the 2008 controller test. So alright, next let's go ahead and do the 8 drive ZFS RAIDZ2. Okay, let's go ahead and create data RAIDZ2, and for this one I'm going to use the other set of hard drives here, so J through Q. Okay, and I'm going to go ahead and create a data set we'll call testing, and just as last time we're going to use 1 megabyte record sizes. Okay, and instead of the regular IO stat, we're going to run the zpool IO stat. Alright, so we see our RAIDZ2 there, and we've got the 8 drives. Let's go ahead and run the first DD test. Okay, and let's go ahead and drop some caches, and we're going to read that back. Alright, so let's go ahead and record those results here. So we got 551 for the initial write, and we got 886 for the read. Alright, next let's do the IO zone test. Okay, benchmarks are done. Let's go ahead and start recording this. So we got about 500 megabytes there. 498. And on the sequential read, I'll record as 5R957. Let's look at the random write. Record that as 368. Okay, next let's go ahead and do the the RAIDZ2 with all 16 hard drives. Create our testing data set. Alright, let's start with the DD test. Okay, Okay, drop to cache, read it back. Alright, let's go ahead and record this as 727, and sequential reads is 1.4, so what is that? 1434. Okay. And next, let's go ahead and do the IO zone. Okay, so that's done. Let's go ahead and record that too. I'm going to round that up to 7. Well, that's 675. For the read, let's round that up to 5. That gives us 1422. And then for the random IO numbers, I'll record that as 647. Alright, next test is RAIDZ2 with 2 sets of 8 hard drives. Okay, so we're going to create one RAIDZ2 set with the first 8, so that's B through I, and another RAIDZ2 set J through Q. Okay, let's create our testing area here, and let's go ahead and run the DD. Drop to cache and read that back. Okie doke. Oops, that's not what we want. Let's record these numbers. We got 741 and we got 1.7. So we'll record that as 1741. Alright, I guess I don't need that other calculator. Let's run IO zone. Okay, tests are done. Let's go ahead and record these final results. I'm going to round that up to 8. 701. And for the reads, round that to 3. 1629. Let's look at the random writes. Record that as 651. I'll round that up. And I'll record that as 80. Okay, so those are our results. Let's compare that to the LSI SAS 2008 setup. So I think we already looked at this earlier, but the RAID 0 for 8 hard drives and RAID 0 for 16 hard drives, we really didn't see much of a difference. We noticed that the sequential reads were a little bit slower in the IO zone test, but pretty much the same with the DD, so who knows, that probably doesn't mean very much. So really no difference at all when you're looking at the RAID 0. And so let's look at RAID, the 8 drive RAIDZ2. A little bit slower in sequential reads here. A little bit faster in sequential writes there, but the numbers are not really significantly different. So I'm looking at this versus that. And yeah, so not really a whole lot of difference. So let's look at the 16 drive RAIDZ2. So this is a little bit higher. And sequential reads are actually a little bit slower. And that could be a little bit significant there. So almost 200 megabyte difference there. IO zone is showing writes are about the same. IO zone showing sequential reads are about the same. So maybe this is just a quirk with the DD test. But IO zone is pretty much showing the same here. Yeah, so not a whole lot of difference there. Let's look at the two 8 drive RAIDZ2 sets. So this is very similar, almost identical there. Just a slightly little bit lower. It's almost identical there. Yeah, so really no difference. This is identical. So what we're looking at here is that basically whether, oh, I should probably change the name of this chart. That should read 2308. Okay, so what we're looking at here is comparison between the older 2008 chipset versus the 2308 chipset, which has a PCIe 3.0. Now, none of these numbers are getting close to, as you'll recall here, we have this PCIe 3.0 connection to the host, and on this test bench machine I actually don't have a PCIe 3.0 capable motherboard system, so we're not able to take advantage of this. But as you can see, we're not anywhere close, so I don't think we're running into any bottlenecks here. The numbers are essentially identical across the board, so there really makes no difference. So the conclusion really is that if you're building a storage server that's only full of hard drives, and these are fairly modern hard drives, they're 4 terabytes, but they're the 7K 6000 series, so there's only a couple years old. And so they're fairly fast. As you can see, they can do about 200 megabytes sequential reads and writes. But in a storage array, full of only hard drives like this, whether you use the 2008 controller or a 2308 really makes no difference at all. I mean, there are a few tiny differences here and there that, who knows, maybe this is just, discrepancies in the testing conditions, although the hardware is identical. Who knows if there are maybe other factors influencing this. But as you can see, since we're running multiple different tests, even though the DD test might show a slight difference, the IO zone test is showing us that there really is no difference, right? So So yeah, you know, the 2308 controllers are usually a little bit more expensive, and so there's really no reason, if so long as you're building a disk array out of regular hard drives, and you know these test cases kind of are close to what your needs are. So this is really a test case, as I've explained in a previous video, focused more on sequential reading and writing of large media files. And so, you know, if you're hosting a file share with lots of media files, your home movies and whatnot, or you're using this to be the backend for, let's say, a Plex streaming server, you know, this would be, you know, kind of what you can expect. And so there really is no reason to spend more on the 2308 so long as this is your configuration. Now, if you are using SSDs, the story might change, and if I have enough SSDs in my spares box, I might put together a video on benchmarks with SSDs. But in any case, the conclusion is really that, you know, there's really no need to get the 2308 so long as you are using just hard drives. Alright, so hopefully that was useful to you guys, and as usual, if you found this video useful, please click on like, and if you want to see more videos, please remember to subscribe. And again, if you're building servers and you need some IT mode HBAs, please check out my eBay store called The Art of Server, and I'll leave a link in the description area for you to find that. Alright, thanks very much guys. Bye-bye.